Hello people, what's up? Welcome to Developer Notes. Let's dive into today's topic, storage classes in C++. In today's video, I will be talking only about auto and static local variables and cover the extern and register in the upcoming episodes. The programming languages use storage classes to let you control the variables, scope and lifetime. Variable scope or accessibility or visibility is where the variable can be accessed or used. For example, if a variable A is defined or declared within function A, it can only be accessed within function A. If I compile this, it gives me an error because it can't be accessed from function B. In other words, variable A scope is limited to function A, and this is because variable A has auto as its storage class. What is variable's lifetime? Variable's lifetime is the duration from the variable's creation till its destruction. So, the lifetime of the auto variable usually starts when the function block begins where the variable is declared or defined and ends when the block is finished. Since the variable A is allocated in stack, when the end of the block is reached, the call to function A is unwinded. So, variable A is destroyed. So let's call the function A again from main. Now, while calling the function A the second time, variable A is reinitialized to 0. That's the reason we will be getting uh, again 1 but not 2. Yeah, we got 1 but not 2. But what if the variable specifier is static? Let me change this to static. Now, the lifetime of variable A would be throughout the program, though its scope is finished already in function A. This makes sense now for the static specifier. I need to save this to compile. If we see the value is written in the next call to function A, if you remember the previous example, the value is not written because variable A is not static. We learned that storage classes don't talk about the size of the variable, but talks where and all you can access the variable and how long you can access them. The storage class specifier is used for determining the visibility, lifetime, initial value, and memory location of any given variable. There are 5 storage class specifiers in C++, including mutable, auto, static, extern, register, and mutable. By default, auto tags along with variables if no other specifier is explicitly specified. If the variable is not initialized, it might hold garbage value. Memory allocation is done on the runtime. This also means it is stored on the stack segment but not heap. As we discussed earlier that the scope is within the block where it is defined or declared. Since it is auto, its lifetime ends when the end of the block reaches. There are more things to cover in static, so I kept the static to the end of the video. Let's see what is static. Static instructs the compiler to keep a local variable in existence during the lifetime of the program instead of creating and destroying each time it comes into and goes out of the scope. Therefore, it maintains the value between the function calls. Static variable preserves its value even after it is out of scope. It remains in memory while the program is running. This also means it is initialized only once. If a function or variable is static, it is local to the file or function where it is defined. We have learned a few fundamentals about static. Let's run through some examples. In the left example, static variable is initialized by function c's return value. We can also initialize a variable with a function's return value, just like variables are initialized by constants. Do you wonder why the function returns 73 randomly but not any other numbers in this program? I literally like the number 73, and I can also say 73 is my lucky number. It is the 21st prime number, its mirror 37 is the 12th prime number, and its mirror 21 is the product of multiplying 7 and 3. And in binary, 73 is a palindrome, 1 0 0 1 0 0 1, which backwards 1 0 0 1 0 0 1. I am also a huge fan of Big Bang Theory. Anyway, that's off topic. Let's try to run the C program on the right. Oh, it throws an error. Static variables are initialized to 0 by default if not initialized explicitly. These can be initialized using only constant literals in C. So we can't use the return value of any function here. So this doesn't work in C. Let's try it in C++. I have the program ready to compile. Let me compile with C++ 1998 first. Okay, we got the output. Now let me compile with C++ 11. Therefore, okay, so it works in both C++ 11 and C++ 98 older version too. This concludes we can't initialize static variables with functions return value, but only by constants in C, whereas static variables can be initialized by value as well as functions return value in C++. In the previous example, we learned the ways to initialize the static variables both in C and C++. The next is classic example and usually used by all developers. In this function d is called thrice, but the variable count is initialized only once in line 8 and preserve the value of the variable count when it comes into and goes out of the scope, which is function d. This is all about the lifetime of the static variable. Isn't this example bit easy? What if I try to access the variable count from main? Can I do that? Accessibility or visibility is limited to the function or file where it is declared or defined, whereas the lifetime of the static variable is throughout the program. This is a bit lengthy than I expected. Okay, we got an error. It says reference to overloaded function could not be resolved. Did you mean to call it? So through this example, we learned that static variables initialization will happen only once and its scope is limited to function d, but its lifetime is throughout the program. So far we have learned static local variable. Let's dig into static global variables. In this example, the variable counter is declared globally in a .h file which is included in linkage exe3.cpp file. Therefore, its scope is as of now limited to this .cpp file, but the lifetime of the variable is throughout the program. Isn't it so obvious what we learned from the previous examples? You can pause here to let this sink in. Let's consider linkage ex3.cpp as one translation unit or compilation unit in which header exe3.h is included. A translation unit is basically a .cpp file with the contents of .h file inserted in a place of each hash include directives. You can learn about translation unit from my previous video which I linked at the top right corner, and also will leave a link to that lessons in the description. Static variables are not visible outside this translation unit. Our source file linkage exe3.cpp. Also, executing this program doesn't create a copy of counter in function e, rather both refers to the same variable and results the same value from .cpp file. Additionally, a bit of warning here, global variables are typically avoided, so static keyword is not used much globally. Let's discuss about static member variables. I promise you guys it's going to be interesting. When we instantiate a class object, each object gets its own copy of non-static member variables. In this case, we have instantiated two nodes class objects. We ended up with two copies of volume, first dot volume and second dot volume. First dot volume is different from second dot volume. Now let's run this. Consequently, this program prints non-identical values 5 and 7. Without static, the member variable is part of the class, and each instance will provide us separate storage for this member variable. Since I have changed the value of the first object, it was modified but not the second object. With static, the member variable has only scope of the class, but there will be only one global storage. Let's dig into this by adding the keyword static. Sorry, we got an error here. Let's compile and see. The error says non-constant static data member must be initialized out of line. We must understand static member variables are not part of individual class objects, or in other words, this member will be shared by all objects. So this means they are treated as global variables. Global variables are usually initialized when the program starts. Due to this reason, static member variable should be defined outside of the class, which is in the global scope. So let me remove this. Let me initialize the static variable with the value 7. Since it is inside the class, we need to specify the class name and the scope resolution operator, and then the variable name equal to 7. Let's rerun this. Okay. Unlike non-static member variables, static member variables are shared by all objects of the class. That's the reason we got identical value for the volume as the address is same for the two objects. Now, if I try to access the static member without this object first or second, it is definitely possible because they are much like global variables. So let me save this and I will compile this again. Okay, we are able to access it without the object name. So they are created when the program starts and destroyed when the program ends. Accessing static members using the class name is preferred over the object names. I guess this video is already a bit lengthy, so I will cover the static member functions and static class in the second part of this video. Static functions are limited or visible only within the file where it is defined. It avoids the function names being made available to the world outside the given translation unit, for example during the linking. I picked up the static free function to demonstrate. This is one of the famous examples. I'm gonna compile the main file.cpp separately. So this creates a .o file. Likewise, um, compiling auxiliary file.cpp creates another .o file. Let's check this. Okay, we got two files, auxiliary file.o and main file.o. Let's link these together. Okay, this is the command for linking. We got the output. Let me run through the flow. It starts from main. Later, it hops to main function in line 14, which invokes the free function in main, which is this one. So we got the first print from line 6. We will get the next print from line 11 as our next function is static function. Once the main function is ended, we will invoke the auxiliary function, which is defined in auxiliary file.cpp. It again has two functions, a free function and the static function. Free function will be invoked from main file. So we got the third output as main free. And then later it will call the static function to print the fourth output from this line number 11. So this confirms static function in main file was not available to the auxiliary file. Here, though each function has the same static function name, it doesn't violate the one definition rule. Rather, each translation unit has its own copy of the static function definition. In C++, instead of static free functions or static member functions, it is recommended to use non-static functions in anonymous namespace to avoid polluting the namespace. I will discuss this in a separate video. Let's see some facts about static. Static variables shouldn't be declared inside the structure because C compiler expects structure elements to be placed together as the value of the structure elements retrieved by counting the offset from the beginning of the structure. So all the structure elements should be placed in the same memory segment. The static usually tags on file scope variables to determine if they are accessible in other translation units. Global static variables are local to its translation unit, so it gives variable internal linkage. Function arguments can't be static variables. Static free functions are local to their file where it is defined. Static member variables has only the scope of the class, which means it will be shared among all the objects of the class. Let's learn the common features about static storage specifier. The value will be initialized when the execution touches the static variable declaration or definition. This is called lazy initialization. It holds the default value as 0 if it is not explicitly initialized. Memory is allocated at compile time or link time because it has to give the value to the assembler. This explains that it will not be stored in the stack, rather data segment which is part of executable. Though its scope are, to be precise, its accessibility is within the block, its lifetime is throughout the program. When we go through all these interview questions, hopefully most of your doubts will be clarified if you have any. The first question is, can we have the static variable in the structure? This we have discussed in the facts about static section. You can pause and listen to the facts section and come back here. The second question is, can we use the static for the members of the class? Yes, absolutely. We have seen already the static member variable. We will discuss about the static member functions in the future videos. The third question is, can a class be static? Yes, again, this will be covered in the future videos. The fourth question is, what is static function? Which one is good practice to use? Static member function are static free functions in C++. Static functions are functions that are only visible to other functions in the same file, more precisely the same translation unit. Neither of them are a good practice to use, but the anonymous namespace is the best option because static free functions can pollute the global namespace. On the other hand, static member functions will be exposed to every other file by including .h file where the class is defined. The fifth question is, where the static variable will be stored in the memory. It will be stored in the data segment if it is initialized. If not, it will be stored in the BSS. The sixth question is, what is stack unwinding? The process of destroying local objects and calling destructors is called stack unwinding. The seventh question is, why volatile and constant are not specifiers like static? They are qualifiers, which adds extra quality to the data type or type, such as specifying volatility and constantness of a variable. Qualifiers just specify how it can be accessed or where it can be stored. The eighth question is, what is lifetime of a variable? It's a kind of recap here. Variable's lifetime is the duration from the variable's creation till its destruction. So the lifetime of the auto variable usually starts when the function block begins and where the variable is declared are defined and ends when the block is finished. The ninth question is, what is scope of a variable or a function? I'm gonna repeat this again. Variable scope or accessibility or visibility is where the variable can be accessed or used. The 10th question is it good to use static global variable? Why? Can we define static global variable in .h file? It is not good practice to use static global variable. There is no hard set rule that tells we can't use static global variables. However, it is avoided because of the ambiguity it creates in the code. Static global variables should be defined in .cpp files, but I had earlier ran through a few examples, if you remember, in the .h where it was defined in .h files, which was wrong. Please avoid defining static global variable in .h file. The last question is, there are two objects for a class. If one of the member variables is static, can the static variable have a separate storage for each object? Why? No, static member variable has a class scope, so it will be shared by all the objects of the class. I hope these are all pretty basic things anyway. All the best for your interviews. Please bear with me till I cover all the topics, and if I missed any facts about static, please let me know in the comment section below. Please hit the jumbo subscribe button and don't forget to click the bell icon. I will meet you guys in another episode. Until that, a lot and lot of hugs and positivity.